In observing health protocols, the minimum fare of the jeepney is 10 pesos in every first 4 kilometers and the additional of 2 pesos per kilometer thereafter. Suppose you traveled for 10 kilometers, how much you are going to pay? And how many kilometers will it take for your 40 pesos? Problem like this is just one of the applications of linear equations in two variables. How do we illustrate real-life application into linear equation and two variables? How are we going to graph linear equation in the Cartesian plane? So just stick around and I will teach you how to learn this lesson in an easy way. If you are new to this channel, kindly hit the subscribe button and the notification bell for you to be updated every time I will upload new math video made easy for you. So let's consider the situation that Top and Bonnie's age combined is 37. Can we write this situation algebraically? Is it possible to find their individual ages? Problem like this can be solved and modeled using linear equation in two variables. Finding the individual age is confusing, but as long as age of one is given, you can definitely find the other. Let's try to illustrate the situation using two variables. Suppose we will let the age of Top as x and y would be the age of Bonnie. Based from the problem, their age combined is 37. So combined means we're adding. So Top's age plus Bonnie's age is equal to 37. So if x is the age of Top plus age of Bonnie, y, and that is equal to 37. So this mathematical equation illustrates the situation that Top and Bonnie's age combined is 37. This is an example of linear equation in two variables. So the definition, if A and B and C are real numbers, and if A and B are not both equal to 0, then AX plus BY is equal to C is called a linear equation in two variables. The number A and B are the coefficient of the variable X and Y respectively, while the number C is the constant. This equation is written in the standard form. So the standard form of the linear equation in two variables is written in the order of ax plus by is equal to c. So we're asked to identify what are the real numbers a, b, and c based on the definition. Suppose we have 3x minus 2y is equal to 7. So a, the coefficient of x is positive 3. B, the coefficient of y, which is negative 2. And lastly, c, the constant is positive 7. How to transform linear equation into a standard form? So we are going to recall the different properties of equality. So suppose we're asked to transform this equation, 5y is equal to 6 minus 3x into standard form. So 5y is equal to 6 minus 3x. So what we're going to do is we will do something such that 3x will be put at the left side of the equation, which is in the form of ax plus by, and that is equal to c. So in this case, we will apply the addition property of equality. So we have to make this negative 3x into 0. So we will add its additive inverse. So we will add positive 3x. So since we add positive 3x here, we will also add positive 3x to the other expression at the left. So simplify. So 3x, we just rewrite. We will write first the 3x, positive 3x. We just copy positive y. Then copy 6. Negative 3x and positive 3x, they are additive inverse, so the sum is equal to 0. What method allows us to do this? Because of the commutative property and the inverse property. Further simplification, 3x plus 5y, and that is equal to 6 plus 0, that is equal to 6. So this is now the standard form of this equation. So a linear equation in two variables have many ordered pair that satisfies the equation. The ordered pair that will make the equation true or correct, we call it a solution or solution set. So what if we will find the possible value of x and y for the age of Top and Bonnie respectively that will satisfy the equation x plus y is equal to 37? What do you think are the values of x and y? In this case, we will only let one of the variable as a certain number. So in this case, we will let x be equal to 1. So the equation is x plus y is equal to 37. Since we let x is equal to 1 by substitution property, so we can substitute x by 1. So 1 plus y is equal to 37 by adding its additive inverse to make it 0. Since we subtract 1 here, we also subtract 1 to the other side to maintain the balance of equality. So, negative 1 minus 1 is equal to 0 and 37 minus 1 is equal to 36. Or basically, what we are doing here, we just transpose the positive 1 to the other side. Its sign will change. The reason behind is the addition property of equality. So 1 and 36, this is the ordered pair, which means that this 1 is the value of x and 36 is the value of y. So to check whether this coordinate is really the solution of this equation, so we will substitute it to the original equation. So x is 1, y is 36. It has to be equated to 37. So 1 plus 36, that is equal to 37. So we are certain that this value of x coordinates will make this equation true. As what I have said, this is just one of the solution. We can find a lot of solution for the value of x and y that if you are going to add them, the value is 37. So let's have another example. Suppose we are asked to find at least two ordered pairs or coordinate that satisfies the equation 2x minus 3y is equal to 6. In this case, we can let any value of a certain variable, but I would suggest we will use the smaller values. So what if we will try x is equal to 0? So again, it is not absolute. We can always let any value of the certain variable. X is equal to 0. So 2x minus 3y is equal to 6. This is the given equation. Substitute 0 to x. So 2 times 0 minus 3y, we just copy, is equal to 6. So 2 times 0 is 0. Minus 3y is equal to 6. So 0 minus 3y is equal to 6. So solve for y. So whatever the coefficient of the variable, that's exactly the same number that we're going to divide both sides. So we will divide both sides by negative 3. So negative 3 divided by negative 3, positive 1y. So the ordered pair is 0 and negative 2. Which means if x is 0, our y is negative 2. Suppose we will let x is equal to 1. So again, substitute 2 times 1 minus 3y is equal to 6. 2 times 1 is 2 minus 3y is equal to 6. So by addition property of equality, we will be able to transpose this 2 to the other side. So it becomes negative 2. So 6 minus 2 becomes 4. So by dividing both sides by negative 3, so our y is negative 4 over 3. So another ordered pair is 1 and negative 4 over 3. Those are the values of the x and y that will make the equation true. So another example, determine if the ordered pair 2 and negative 3 satisfies the given equation. 2x minus y is equal to 7. So we are checking if this value satisfies the given equation. So how are we going to do this? So basically, we are just going to substitute the value of x and y to the given equation. So our equation is 2x minus y is equal to 7. So since our x is 2, substitute. So 2 times 2. Then minus, our y is negative 3. Put them in the quantity. Then is equal to 7. So 2 times 2 is 4. Negative times negative 3 is positive 3. And that is equal to 7. So 4 plus 3 is 7. So therefore, this value 2 and negative 3 is the solution of this given equation. What if this linear equation in two variables will be illustrated in the Cartesian plane? So we call it a graph of this linear equation. So in graphing linear equation in two variables, it can be done in three different ways. It could be done using the table of values of x and y, by intercepts method, or by the slope-intercept method. In this video, we'll be focusing on graphing a linear equation in two variables using the table of values. So first, how are we going to do it? So we'll find three ordered pair. So we have a postulate that states that 2 points determine a line. So we need at least 2 points to have a line. In this case, for verification purposes, we will find at least 3 ordered pair or 3 points. Second, we will plot these points in the Cartesian plane and we will draw a line that passes through this particular point. Top and bonus age combined is 37. So illustrate their possible ages. So again, we will make a table. So this is x and y. This is top's age and this is bonus age. Suppose top's age is 1. What will be the age of Bonnie? So for x is equal to 1, so basically we just substitute it. So we found it already that the value of y is 36. So this is 36. If x is equal to 2, so substitute So 2 plus y is equal to 37. So by addition property of equality, transpose 2 to the other side, it becomes negative 2. So 37 minus 2, it would be 35. So this must be 35. If x is equal to 3, so 2, substitute. So 3 plus y is equal to 37. Again, by addition property of equality, transpose 3 to the other side, that would be negative 3. So 37 minus 3 would be 34. So this is 34. So you can write these two numbers as an ordered pair. So the ordered pair is 1 and 36, 2 and 35, and 3 and 34. So plot these points in the Cartesian plane. Since the values of y is way bigger, so we will just calibrate. We will divide the y-axis by 5 units. So if x is equal to 1, the value of y is 36. So approximately, it's here. So that would be the location of 1 and 36. If x is 2, that would be 35. So it is here. Then if x is 3, that would be 34. So lower a little to 35. So that would be here. So connect these 3 points. And it basically a straight line. The graph of the linear equation in two variables is a straight line. So this is the graph of the equation x plus y is equal to 37. So example number 6, graph 2x plus y is equal to negative 4. So again, by table of values, so we can assign any value of x. So preferably, we will choose the smaller value. Suppose we let x be equal to negative 2, 0, and positive 1. So for x equal to negative 2, so our equation is 2x plus y is equal to negative 4. So substitute, so 2 times negative x is negative 2, then plus y, and it is equal to negative 4. So 2 times negative 2 is negative 4. We just copy y, we just copy negative 4. So further simplification by addition property of equality. So solve for y. So y must be isolated at the left. So negative 4 must be transposed to the other side. So negative 4, it turns to positive 4. So negative 4 and positive 4, they are additive inverse. So the sum is 0. So when x is equal to negative 2, y is 0. What if x is equal to 0? So substitute. So 2 times 0 plus y, that is equal to negative 4. 2 times 0 is 0. Then plus y is equal to 0. So therefore, y is equal to negative 4. Next is x is equal to 1. So substitute again. So 2 times 1. Then plus y is equal to 4. So 2 times 1 is 2. Then plus y is equal to 4. Transpose. So y is equal to negative 4 minus 2. So negative 4 minus 2. So we just add the two numbers. 4 plus 2 is 6. Copy their common sign. That is negative 6. So that would be negative 6. So these are the ordered pairs. Negative 2 and 0. 0 and negative 4. And 1 and negative 6. So graph them in the Cartesian plane. So negative 2 and 0. So it is located here. Then 0 and negative 4. So it's going down. Located here. Then 1 and negative 6 be located here. So connect these three dots and this illustrates the graph of the equation 2x plus y is equal to negative 4. Example number 7, graph 3x minus 2y is equal to 6. So table of values. So we'll assign any values of x, but we prefer to have it a smaller number. So 0, 1, and 2. So for x is equal to 0, so 3x minus 2y is equal to 6. Substitute. Instead of writing x, substitute it by 0. So 3 times 0 minus 2y is equal to 6. So 3 times 0 is 0. Copy to negative 2y. Copy 6. So 0 minus 2y is negative 2y. Divide both sides by negative 2. So 6 divided by negative 2, that is negative 3. So when x is equal to 0, y is negative 3. What if x is equal to 1? Substitute 1 to x. So 3 times 1 minus 2y is equal to 6. 3 times 1 is 3 minus 2y is equal to 6. So by addition property of equality, so transpose 3 to the other side, that becomes negative 3. So what is left is negative 2y. So negative 2y, 6 minus 3 is 3. Divide both sides by negative 2 to solve for y. So negative 2 divided by negative 2 is y. So 3 divided by negative 2 is negative 3 halves. In decimal, that is negative 1.5. So that would be the value of y when x is equal to 1. If x is equal to 2, so substitute 3 times 2. minus 2y is equal to 6. So 3 times 2 is 6. Minus 2y is equal to 6. So transpose. So negative 2y is equal to 0. So divide both sides by negative 2. The y is 0. So y is 0 when x is equal to 2. So the ordered pairs are the following. 0 and negative 3. 1 and negative 3 halves. 2 and 0. So plot these coordinates in the Cartesian plane. 0 and negative 3 is here. The next is 1 and negative 3 halves. So 1 positive x. So 3 halves is 1.5. So if this is 1, this is 2. So 1.5 is somewhere at the middle of 1 and 2. So that would be here. 2 and 0. So this is the location. So connect them. So this will make a straight line. So this is the graph that illustrates 3x minus 2y is equal to 6 in the Cartesian plane. Example number 8. Graph x is equal to 4. So this equation can be rewritten into a form of x plus 0y is equal to 4. So x plus 0y is equal to 4 is just the same as x is equal to 4. So in making table of values, we will focus on this equation. So since we have no variable y here, so we will now let y be an any number. So again, we can assign any value to represent for the value of y, and we will find the value of x afterwards. So we can assign any values of y, but we will prefer the smaller values. So for y is equal to 1, so x plus 0y is equal to 4. So substitute. So 0, our y is 1, is equal to 4. So 1 times 0 is 0. So x plus 0 is x, and that would be 4. When y is 1, our x is equal to 4. So what if our y is equal to negative 2? So x plus 0 plus x plus 0y is equal to 4. So substitute again. X plus times 0 times negative 2 is equal to 4. So 0 times negative 2 still 0. So x is equal to positive 4. When y is equal to negative 2, our x is positive 4. So what if our y is equal to positive 3? Same is true. So when y is positive 3, our x is positive 4. So as you can see, in the equation x is equal to 4, we can assign any value of y. However, the resulting value of x is always 4. So these are the ordered pairs. Now, if we graph them in the Cartesian plane, so first, 4 and 1 is should be here. So 4 and negative 2, it must be here. So 4 and positive 3. So 4 and positive 3 is up. So connect them. So this will make a vertical line. So the graph of the function, or the graph of the equation x is equal to a constant is a vertical line. What if we have equation 2y is equal to negative 10? So again, this equation 2y is equal to negative 10 can be written into 0x plus 2y is equal to negative 10. So in this case, in using table of values, since y is the variable given, we will assign any value of x. So for x is equal to 1, solve for y. So given this equation, so 0 times 1 plus 2y is equal to negative 10. So 0 times 1 is 0 plus 2y is equal to 10. So 2y is equal to negative 10. Divide both sides by 2. So that would be negative 5. So when x is 1, y is negative 5. So what if x is equal to negative 3? So same process, substitution, simplification, y is negative 5. What if x is equal to 4? Same is true. Substitute, then simplify, transpose, addition property of equality, and it gives us the value of negative 5. So if there is no x in the equation, you can assign any value of x, but the value of y remains the same. So as you can see, to illustrate this one, so these are the ordered pairs. So if we grab this ordered pair in the Cartesian plane, so this is how it look like. Negative 3 and negative 5 is here. 1 and negative 5 is here. Then 4 and negative 5 is also here. Connect them. So this is the graph of a horizontal line. So if the equation given is y equal to a certain constant, So its graph is horizontal. A while ago, if x is given, there is no y, and that is equated to a constant, the graph is vertical. So in this case, this is the graph of 2x that is equal to negative 10. And if you like this video, kindly hit the like button, and in the comment section, kindly send me your thoughts about this video and how could I possibly help you to learn math lesson in an easy way. Thank you for watching. See you in our next video.